Hello everyone, welcome to today's class. Today we will be starting with a new topic known as application of derivative, in short AOD. Okay. And the first subtopic is rate of change. Okay. So for that we have to now understand the meaning of dy by dx. What is the meaning of this? Okay. So before even going to that, let's just understand what is dy, what is dx. The meaning of dx is change in x. Usually d represents small change, so I'll write small change in x. Okay. Similarly, dy means small change in y. dr will mean small change in radius. Okay. R will have the same notations. Okay, the same standardization. A means area, R means radius, V means volume. Okay, same area. Now let's understand dy by dx. What is the meaning of this? The meaning is change, not exactly change, rate of change in y. Okay, with respect to x, means how fast y is changing with respect to your x. Okay, suppose y is some function of x. As x changes, y also changes, but at what rate? That's dy by dx. Okay. Now, usually when we talk about change is majoritively defined with respect to time. Okay, so if nothing is mentioned, then by default it's always with respect to time. Okay, with time everything changes. Okay, so usually the change will be defined with respect to time. So suppose dx by dt. What is the meaning of that? Rate of change in x. The moment a question says rate of change in x is something, that means it is talking about dx by dt. So if nothing is mentioned, by default just with respect to time means time dt. Okay, so let's say he says dv by dt. What's the meaning of this? Rate of change of v represents volume. Oh. Rate of change of volume. Okay, so this interpretation is very much important here. Okay, so I'm putting everything with this in box. All right. And the second thing that you have to understand, that the change can be increasing as well as decreasing. Something can change in a way it's increasing. Okay, something can decrease also. So how can we define that in terms of a so we use positive and negative to define it. So let's say something is like dx by dt. Okay, let's say the point is this quantity, or let's say simply let's take some physical quantity. Physical quantity will be radius. Okay, so the radius of a, let's say a circle can increase or decrease. So if it's increasing, then we'll take it positive. If it's decreasing, it means negative. So it automatically implies positive, negative if it's increasing or decreasing. So while doing a question, suppose you are solving and you got your dr by dt as negative, what does that imply? That the radius is actually decreasing. Okay. Second thing, if the question says that the radius is decreasing at 10 meter per second, something like that. So in that scenario, what will happen? The question will give you only the quantity, the magnitude, but you yourself have to apply dr by dt as minus 10. Okay, if the radius is changing with the rate of 10 meter per second, let's say, or 10 centimeter per second, then if it is increasing, you apply plus 10, dr by dt is equal to plus 10. If it is decreasing, then apply minus 10. Okay, all right, increasing, decreasing is done. One more thing that's important is unit. Sometimes it's difficult to judge from language that what quantity is given, so unit helps also to identify. Plus your answer will be given units. So let's see. So I'll start from here. dy by dx will be like let's say centimeter by centimeter or meter by meter. Okay, so I'll write SI unit Okay, so this one will have, I'm not talking about this one because usually we'll not have these quantities. We'll always have rate of change with respect to something or with respect to time. So something like this dy by dx, it will be centimeter per centimeter or meter per meter, and don't say that we'll cancel it. No, it will be written like this. Okay, dx by dt will be like centimeter per second. Okay, so if you know a little bit physics, you can understand this. Unit of length divided by unit of time. So centimeter per second or meter per second, depends on the question. Volume is given in centimeter cube per second or meter cube per second. I forgot to mention the area, but I'll add it here. So let's say you have dA by d, sorry, dA by dt. Okay, so what is the meaning of that? Rate of change of area. Okay, and the unit, its unit will be centimeter square per second or meter square per second. Okay. All right, this is done. Increasing, decreasing we have talked about. Now let's take a look at the questions and try to understand with help of them. Okay, so let's see. Let's start with the basic one. The first time you'll have to slightly understand the method, how to write things. Once that method is clear, you'll be pretty much comfortable. He is saying find the rate of change of area. Okay, so first of all, whenever a language question like this is given, you have to convert this in mathematics. So means he's asking for what? Rate of change. So if nothing is defined, that means by default it is asking with respect to time. But let's read the complete question. Find the rate of change of area per second with respect to its radius. That means it's asking for dA by dr. Okay, if the question says if this line is not mentioned, with respect to, okay, or with at least is there, with radius or something, then it was dA by dt. So he's asking for dA by dr. Fine. Okay, it's a circle question. So we'll write the basic formula. What is the formula of circle? What is the area? Pi r square. Now you differentiate both side with respect to r. Okay, so in that says dA by dr will be differentiation of d by dr of pi r square. And now because we are differentiating r square with respect to r, so it's easy. So dA by dr will be 2 pi r. Okay, and the question already gives us that the radius is 5, so we'll put the value 2 pi into 5, so 10 pi, and the unit will be, it's given in centimeter, so 10 pi centimeter square, that's area, per centimeter. Okay, you'll write it like this, and don't say centimeter will cancel and this unit will be centimeter. Yes, but it is denoted like this, centimeter square per centimeter, means for 1 centimeter change in radius, your area is changing by 10 pi centimeter square. That's the meaning of it. So that's why it is written like this. Again, meaning will not be asked, just for your understanding, that unit will be written like this. All right, so the idea is to write the basic formula and then differentiate accordingly. Let's look at the next question. All right, so this one says the volume of a cube, so this time it's a cube shape, okay, is increasing, means we have to take the change positive. Okay, increasing means positive. Okay, the rate is given as 9 cubic centimeter per second. So by default you can see here per second is mentioned. So that means what is this quantity? 9 centimeter cube per second. Okay, 9 centimeter cube per second. Now with the help of unit you can also define what could this be, what could be this quantity. Centimeter cube is volume, the second is time, so this is nothing but dV by dt. So that's why sometimes units is helpful. Okay, I'm not saying that you cannot identify from the language, it's that unit can also help. Okay, dV by dt is given to us, is saying how fast the surface area is increasing. He's saying how fast the surface area is increasing. Okay, and the reason I'm taking this positive because it's mentioned. Okay, so we have to calculate how fast the surface area increasing means. How fast means the rate at which it is increasing. That means he is asking for dA by dt. All right. When the length of the edge means the side is 10 centimeter. Okay, so you have a cube whose side is increasing and the length at a moment is 10. Okay, so the value of a that we have to take is 10 centimeter, but we'll use that at last. Okay, it's increasing, but at the moment it was 10 centimeter. How fast the area is increasing given that the volume is increasing at 9 centimeter cube per second. All right, so we'll start from the given information, this one, that the volume of cube is a cube. Now if I differentiate both sides with respect to t, left side will become dV by dt, no problem. How will you differentiate this? D by dt of a cube. Okay, now this is something like if I ask you to differentiate y square with respect to x, how do you differentiate? You assume that this differentiation is with respect to y. You differentiate y square, you say this is 2y, and then you say additionally y dash with it, or dy by dx. This is how we used to do in the differentiation. So same thing happens here also, it's just that the variables are different, the names are different. So we differentiate assuming it's differentiable with respect to a, so that is 3a square into then a dash or dA by dt. You have to understand one simple rule, that is nothing but chain rule effectively. Okay, and you can relate this with this d by dx of y square, how you used to differentiate that. Okay, all right, now this is done. Okay, the value is this dV by dt. Now what is the value? 9 is equal to 3a square dA by dt. All right, let's get dA by dt from it. So dA by dt is equal to 3 by a square. Okay, mark this as 1, we'll use it later. Now same thing, this is just to relate. Now you have to do with surface area. Surface area is 6a square. So again ds differentiating both sides with respect to time. So differentiation of s is ds by dt. Okay, surface area na. So I was writing a, so I'll use a. Let's keep the symbol same. I was taking area as a, so area capital A. Okay, yeah, that's okay. So differentiate it, 6 is constant, no problem. So a square differentiation is 2a, so 12a and additionally dA by dt. Now this is why I was calculating this dA by dt, because I needed the value of dA by dt that could have been used from here. So use this, so you get d capital A by dt, capital A is area, so 12a into 3 by a square. So that's a cancel, so you get 36 by a. Now you know the value, a is 10 na, so put the value, so 36 by 10, that's 3.6, and what will be the unit? It will be centimeter was given na, centimeter square per second. That will be the answer of this. Okay. So remember, you have to put the value at the last, don't use before that. Okay, so just an application of chain rule here again. All right, let's look at another question. The question says you drop a stone in a lake and waves are produced in circle, and we see the waves are actually traveling outwards at a speed of 4 centimeter per second. Now this is going to confuse you slightly. Okay. At an instant when the radius of the circular wave was 10, so he's giving you the value of this. How fast the enclosed area is increasing. How fast? The moment he's saying fast, he's asking about the rate at which it is increasing or decreasing. That means he's asking for dA by dt. That's the question he's asking. But point is, how do you get with this speed? Speed is 4 centimeter per second. This is again where this could be helpful. First of all, it's the waves are in circular nature. Okay, so there are effectively two parameters. One parameter, radius. Okay, area we calculate, but effectively there is only one single parameter. Look at the unit, centimeter per second. So 4 centimeter per second. The only possibility this can be is dr by dt. Okay, because the wave, when it moves, it will create a bigger circle like this. So this is the distance traveled. So this change is actually for the change in radius. You can interpret from that also. All right, this is done, this is done. So now what we do, area is equal to pi r square, pretty much same as the first question, but this time you differentiate both sides with respect to t. So dA by dt is differentiate this, so you will write 2 pi r into dr by dt. Okay, you differentiate assuming it's differentiation with respect to r, but then additionally add dr by dt. Same thing. I think radius, this dr by dt was given, it was increasing. That's why I'm always taking positive. So 2 pi, radius is 10, this dr by dt is 4. So 40, 80 pi. I'm writing answer in terms of pi. It depends on the question. Okay. So 80 pi, and the unit will be centimeter square per second. Okay, that's the answer. The thought process is all these questions are about. Okay, as such, rest differentiation point of view, this is very simple. The interpretation should be clear, because either you will be able to start the question or you won't be able to write even the single step. Okay, all right, next question. Okay, this is it. Now the sense of increasing decreasing will make more sense. You can see in this question, the question says that the length of rectangle is decreasing at rate of 3 centimeter per minute. So this time it has taken time in minutes, so not a problem. Okay, but width is increasing. Okay, so length is decreasing, width is increasing at the rate of 2 centimeter per minute. So let's first of all write this mathematically. Let the rectangle length is taken as x, so that means dx by dt. We'll write the value as 3 centimeter per minute, but since it is decreasing, we have to put a negative sign. Similarly, width he has taken as y, so dy by dt. We'll take that increasing, so we'll write plus 2 centimeter per minute. The value of x and y is given, we'll use at last. He's saying find the rate of change of perimeter. Again, nothing mentioned with respect to what. That means he's asking by default with respect to time. So first of all, let's write down the formula of perimeter. That's 2 bracket L plus P. So dP by dt will be 2 times dL by dt plus dB by dt. Okay, actually length and breadth were x and y, so you replace LBA with xy. Okay, so right, change it in next step. So 2 into what was the length, dx by dt, breadth was dy by dt, and we know the values. Now put down the values. 2 into minus 3 plus 2, so that's minus 2 effectively. Okay, so perimeter is actually decreasing at the rate of 2 centimeter per minute. Keep the unit same. All right. Next, we have to talk about area of rectangle. What is the area? Area is equal to length into breadth. So basically xy. Now, if we differentiate this dA by dt, that means we have to differentiate xy. So clearly, multiplication of two things, that means UV rule. So that means x dy by dt plus y dx by dt. Differentiate one variable at a time, keep the other same. So basic UV rule. Now to get the value, we need to put the value of x, y and dx by dt, dy by dt. Let's put down the value. X is 10, dy by dt was 2 plus y was 6, dx by dt is minus 3. So 20 minus 18. So actually, interestingly, area is increasing. Perimeter is decreasing, but area is increasing. Plus 2 it is coming. So plus means by default it is increasing, and this is perimeter is decreasing. Okay. Area will be, the unit will be centimeter square per minute, because time here they have taken in minutes, so we'll write in minute. No need to convert into seconds, nothing like that. Okay, unless and until the options are created like that. Okay. So, all right. Then a very simple idea is there. Okay, that's regarding marginal cost. Okay, and the revenue. This is again application, again straightforward, nothing else. The question itself will define what's marginal cost, but after this you should know what's marginal cost. So first of all, let's say some production unit is there. Okay, you are in a factory and X units are produced. Okay, and the total cost is given by this, some function of the units. Okay, if you increase the number of units, the cost of production usually decreases. Okay, but depends, sometimes it increases also, the total cost of production. Okay, all right. So the question says find the marginal cost when 3 units are produced. Units are represented with X. Now marginal cost, first of all you need the effective meaning, but I'll write it directly. Marginal cost is nothing but dC by dx. Okay, rate of change of total cost with respect to your X. Okay, that's it. You need only this. That means you have to differentiate. So in order to get the marginal cost, this is your formula. Directly remember this if the question comes for marginal cost. Okay. Sometimes students leave this question just because they don't know the word marginal cost. So differentiate this. So if we differentiate with respect to X, so that's normal differentiation, 0.0 0.015 x square minus 2 will come down, 0.04 x plus 30. Okay, that's the differentiation, and put the value of x as how much? 3. So done. So 0.015 into 3 square is 9 minus 0.04 into 3 plus 30. Okay, so that will come out nearly 30 point something effectively. Okay, so 30.12 roughly. Okay, approximately. Close enough, because all these are decimal values. Okay. Same thing you can do with your revenue also. Okay, marginal revenue. Okay, same thing, same meaning. Okay, whenever the word marginal comes, means you have to differentiate. That's the overall conclusion from this. Revenue generated by some sale of units. Okay, something you are selling and you are getting revenue generated. Okay, so he's asking for marginal revenue. So again, marginal revenue is nothing but dr by dx, the revenue generated with respect to x. Take that as your formula. Okay, so just solve it. So again we differentiate. So 6x plus 36 is saying calculate when x is 5 units were produced. So put down the value, 30 plus 36, that's 66. Okay, simple enough. Okay, all right. Let's look at a question. Okay, so a question can be presented to you in a practical sort of way. So the question saying a balloon which always remains spherical has variable radius. Okay, this one is pretty simple as such. No, not this one, sorry. This is pretty straightforward. You'll be able to do this. You can take that as your practice question. I'll get another one. Do this instead. Okay, so that's for your own practice. You can practice it. It's very simple, very straightforward. Okay. Now this time the question is saying, he's saying that the balloon is which always remains spherical, again being inflated by pumping 900 centimeters of gas per second. Now sometimes this quantity is not clear. What is this? Again you can take the help of the units. What is the unit? Cubic centimeter per second. That means he's saying this is volume. This is nothing but dV by dt is 900 because it is increasing. You are pumping the radius. He's saying find the rate at which radius of the balloon increases when radius is 15. So R value is given to you. dV by dt is given to you. Centimeter cube per second. So relate it. First, what is the formula of sphere? So you need the basic shapes: sphere, cube, cone, cylinder. These kinds of shapes, basic shapes will be required, or the basic formulas. Your surface, curved surface area, lateral surface area, volume. Those formulas will be required directly here. Okay. So volume is 4 by 3 pi r cube. Now you have to do dV by dt. So do dV by dt is equal to 4 by 3 pi into 3r square, r cube differentiation 3r square into dr by dt, because we are differentiating with respect to time. So this becomes 4 pi r square dr by dt. This is dV by dt. Put down the value. That's 900. 4 pi r square is r square, 15 square, 225. Okay. So dr by dt. Let's calculate dr by dt. I'll calculate it in terms of pi only. So dr by dt comes 900 upon 4 pi into 15 into 15. 225 into 4 is, I think, there. No? Directly we can do this. 15 is 225 and 400 800. Yeah, 800, and this is also, so this is nothing but 4 times of it. 4 also cancels, so you get nothing but 1 upon pi. So 1 upon pi centimeter per second. Okay, you can put the value of pi also, 22 by 7, or if the options are like that, or the question really wants you to give the answer as decimal or something, you can calculate, but 1 upon pi is okay. That's the correct answer. Okay, marginal cost, this is done. Okay, let's take this question for instance. Again, not always the question will be regarding surface area volume. Sometimes the questions can be related to some other topic also. That's the beauty of maths actually. You can relate it with anything. The perfect tool. So the question is saying a particle is moving along a curve and the equation is given to you. Find the point on the curve. Okay, so it's some sort of curve. A particle, let's say it's moving along this curve, hypothetically. Okay, y-axis, x-axis. He's saying find a coordinate point on curve. That means we have to find a coordinate, okay, at which y coordinate is changing 8 times as fast as x coordinate. Okay, so y coordinate is changing, the change in y. Okay, Remember, I gave you the basic definition of dy and dx. What is dx? Change in y or small change in y. D means small, of course, but basically dx dy means change in y, change in x. Okay, now let's come back to the question. Y coordinate is changing, means dy, okay, is changing. Is means equals to 8 times, means 8 multiplied by x as fast as x coordinate, means the change in x also, that means dx. Okay, all right, so this is nothing but dy is equal to 8 dx. So I can say dy by dx is 8. So the question is directly or indirectly saying dy by dx is 8. Now you have to tell the point at which this is happening. Okay, so what we know, what's y? 6y is this, na? So put the value of y. Dy by dx is dy dx of x cube plus 2 by 6. We have to differentiate this and we have to get the value equals to 8. So differentiation of this becomes simple. 3x square by 6 is equal to 8. So x square by 2 is equal to 8. X 16. X is equal to plus minus 4. Remember, we are solving for coordinates, so negative is a possibility. Alright. Now that you got the value of x, accordingly you can get the value of y, because he is asking for not the value of x but the point itself. So we know that is at this point where x is either 4 or x is minus 4. Okay, so for x is 4 or minus 4, this is happening, this condition is true. Dy by dx is 8. Calculate your y accordingly. So y is coming how much? We are saying 6y is equal to x cube plus 2. So let's write down here also. So for when is x is 4, so 64 plus 2 by 6, that's 11. And when x is 4, okay, and when x is minus 4, it will come in fraction, I think. Y is x cube plus 2 by 6, so minus 64 plus 2 by 6 minus 62 by 6, that's minus 31 by 3. Okay, so the coordinate is 4 comma 11 and minus 4 comma 31 by 3. Both are the coordinates at which the condition that is given is correct. Okay, all right, let's look at another question. Okay, this one is a good question. Again, a practical situation. The question is saying you have a ladder with yours, okay, and it is leaned against a wall. Okay, all right. So let's say this is your ladder. Okay. Okay. Let's say that the distance from the foot of the wall, this distance to the bottom of the ladder is x, and let's say this distance is y. Okay. Okay. Now the bottom of the ladder is pulled along the ground away from the wall. That means this point is moving in this direction at the rate of 2 centimeter per second. Now think, what is this 2 centimeter per second? If I'm talking that the distance of bottom of the ladder from the wall is x, so what is this? Centimeter per second. It has to be dx by dt. Okay, and by default your height will decrease, this height of the ladder that I've taken as y. By default, if bottom comes down, the top will also come down. Sorry, bottom is moving forward now. All right. The ladder is 5 meters, so this ladder is for 5 meter. He's saying how fast the height of the wall, how fast the height of the height on the wall is decreasing when foot of ladder is 4 meter away. So this is the value of x. Okay, the foot of ladder. This is the foot of ladder. So what do we really need to calculate? How fast? Fast means rate with respect to time. Height is decreasing. That means height is represented here by y. Means the question is asking dy by dt. Calculate this dy by dt, and of course it will come negative. Okay. So far it was all about area, volume. So formulas were directly there. Now right now you don't have anything to start with. But if you look at this triangle, you can see this is a right angle triangle. So the starting of this question is the key part, that you can write Pythagoras, x square plus y square is equal to phi square. Okay, and now you differentiate with respect to time. So x square differentiation 2x dx by dt, y square differentiation 2y dy by dt is equal to differentiation of phi is constant, so phi square is also constant, so differentiation becomes 0. Okay, so you can take 2 common and eliminate this. Effectively you get x dx by dt is equal to minus y dy by dt. Okay, or put the negative here, whatever it is needed. Okay, all right. The value of x is given. In order to get the value of dy by dt, so if we want to calculate dy by dt, we need to write minus x by y dx by dt is equal to dy by dt. We have the dx by dt, this quantity is known. We have the x, we need y. So before putting all the values, we need the y. So if you look at the ladder, when x is 4, ladder length is 5, what will be this height? Use the Pythagoras, y will be 3. Okay, 3, 4, 5 is a standard triangle, you should learn this. 12, 5, 13 it's a standard triangle, right angle triangle. 8, 15, 17 is a standard triangle. Okay, 8, 6, 10 is a standard triangle. Okay, if you learn this, your calculations become faster. Minus x is 4, y is 3, dx by dt is 2, dy by dt. So it is coming minus 8 by 3 centimeter per second. At this rate, the height is decreasing. That's the answer. Okay, negative represents the height is decreasing. Okay, all right, this is done. Last question, another practical situation. Okay, so this time sand is pouring at rate of 12 centimeter cube per second. Again, it's just saying sand is pouring, he hasn't told you anything about it. But if you look at the unit, that's why units are important. Centimeter cube represents volume. That means this is du by dt. So du by dt is 12, that we know. Okay, and the falling sand forms a cone. So this time he's talking about cone. I told you to learn the basic shapes, those are very important. Okay. All right, so it is forming a cone. Okay, radius r, height h. Okay, in such a way that height of cone is always 1/6 of the radius. So he is saying that the relation that the height is always 1/6 of the radius. Okay, or I can say radius is 6 times the height. Okay, we'll see which one to use, accordingly we'll change it. Okay, fine. He's saying how fast the height of the cone is increasing when height is 4 centimeters. The value of h is given, but he is asking how fast the height is increasing. So let's look at the formula. What is the formula for volume? Because this dv by dt is given, and it is creating a cone. So what is the formula relating the volume of a cone? That's 1 by 3 pi r square h. Okay. It will be better that if we create a formula, because we already know that this condition is always true, h is 1/6 the radius or r is 6h. So replace this value. So 1 by 3 pi, radius is 6h, so 36h square into h. Effectively you get 12 pi h cube. Okay, so you have now volume in terms of directly height, because radius is always 6 times h as per the question. Now differentiate with respect to time. So dv by dt, simple enough. 12 pi is constant, 3 will come down, so 12 pi into 3, so that's 36 pi. 36 pi h square into dh by dt. Okay. Now dv by dt was already given to us. Let's put down the value. 12 is equal to 36 pi. Height, I think he has given us the height 4 centimeter. 4 square is equal to dh by dt. Again, I'll write this answer in terms of pi only. So this becomes 33. So 1 upon 4 square is 16. 16 into 3, 48. So 1 upon 48 pi is dh by dt. At this rate, the height is increasing, and the unit in the question is everything was in centimeter and seconds. So this is centimeter per second. Okay. All right. So only the key information required to solve any question of this sort is understanding what is given to you and what is asked. How fast it is increasing, dh by dt. Unit also helps a lot. Okay. All right. That covers the first subtopic of this. Okay. All right. That's it for this class. See you in the next class. Good day, everyone.